Hey everyone, Al here. How are you doing? All right. Let's see that we're getting everything to work here. This does not go through as it should. Let's see why. Oh, that's why. Here it is. This is better. Look at my beautiful screen in the background. Hopefully audio works. Let's adjust the microphone a little bit. Hopefully you're all hearing me correctly. Let's pick some other beautiful AI generated, safe to use music. All right, so here is what's going on. I am here to start a fun project. This project is just like a lot of the things I do here on the stream. First of all, I want to say hi to Casual Noises. Hello, Al from Antwerp. Antwerp is in Belgium, right? That is awesome. And audio is good. Awesome. I'm very happy. So this stream would be me doing a little rhythm game. Rhythm games are, in this case, would be more something along the lines of something like DDR, one of my favorite games. It's a game that was introduced to me by my mentor in this field, which is Jamie. He taught me that game quite a number of years ago, and I love it to this day. And I've always wanted to do a little rhythm game, so this would be a chance to do that, and maybe something helpful for me to get a few things in the process. I'm going to do it mostly in JUCE for a number of reasons, which we'll probably talk about. But one would be that unlike other things I'm sometimes doing on this channel, I am extremely familiar with JUCE, so it's hopefully we're going to be a smooth experience on that side. There's going to be some perhaps complication on the making the game side, but there's a lot of things here that I kind of know how to implement, at least the bits of them. So there will be maybe some teaching moments about that. And yeah, so as I always say, I'm streaming this on a few platforms: YouTube, Twitch, Facebook, LinkedIn, Instagram, and X, I think. Probably. Anyway, if you're seeing this, you can just comment. I would post your comment on screen so other people from other places can see it, and we can have a chat. I'm going to get pretty technical pretty soon. I'm going to start from zero, absolutely from scratch, and I'm going to set up a lot of things that are more to do with like general JUCE framework stuff that I actually have to set up in a lot of projects that I've worked on, especially for UI and for buffer processing and for sequencing. So, pretty much all this stuff I'll put as open source. So maybe it's gonna, there's gonna be little bits here that are gonna be useful for some people. And yeah, so I'm just checking that everything works as it should, and everything's connected. Let's see that I have everything that I need. And we can get going. All right. So what I'm going to do, first of all, I'm going to start with a template. Basically what I'm going to do is, there's a template on GitHub that I made that some people like, that's called JUCE CMake repo prototype. It's a prototype to start things with JUCE. We're going to analyze a little bit of that in a second, and we are going to very quickly see why is it useful, take the things we like from it, remove the things we don't like. But since it's my templates, it's going to be hopefully straightforward for me to use. Yeah, so I'm just going to use this template, create a new repository. This one is going to be public. Let's call it rhythm game. I don't know what's going to be after that, but rhythm game. An experimental rhythm game in JUCE C++. So here you go. This is what it is. Create my repository. And I'm going to go to my IDE, which is CLion, and I'm going to clone it. There you go. Some of the stuff moved to the other window. Ask me to set up a debug configuration. Let's use debug. It already does a few things by default that are probably useful. Let me move myself a little bit away so you can start seeing what's going on. Hopefully now I'm less interruptive. Maybe I'll move myself to the other side. Here we go. Maybe this would be maybe, I don't know. Maybe the other side would be better because it might be a little file list here. I don't know. We'll see. We'll see if this is going to be actually be interruptive in the code. So a bunch of stuff this is bringing. The one thing that I don't like that this does, and I probably should change the repo to do that. In this is that one of the things that this repo does is that it clones JUCE as well as some other dependencies from GitHub. And this cloning takes a long time. I don't know why JUCE takes so long to clone, but it's very slow. So let's start by creating a nicer, smoother developer experience. The one thing I wanted to try is JUCE GitHub. And instead of doing that, I am going to grab a released version of JUCE. I think I should be able to do that. So there should be a release. How do you find those? The actual binaries. There it is. But not that. The source code. That's what I need, right? Yeah, so I should be able to just grab this as a URL. And instead, it's using this syntax for CPM. We'll talk more about CPM later and why I'm using it. But I probably can do something like cpm.sync. Checking a couple places, see if my stream actually does what it should be doing and streams the actual video and not something else. Okay, so cpm.cmake is a little wrapper around cmake fetch content that does some other extra things. And there should be a way here to do something like here it is. So I need something like name. I think it's something like name, JUCE. And then it's the URL, if I remember correctly. So the URL can be the one that I got from the JUCE repo with a zip. I think I should be able to do that. Is that enough? I need something else. We'll discover in a second. Okay, I think this looks better. Let's see if now the whole configuration bit is going to be fast. There is something that JUCE has to do first time it does is that it builds this thing called JUCE aid. So that's actually a compile step. Yeah, I probably need to move myself to the other side. Let's move here. Maybe, let's see if I can do that without tearing out my setup. Yeah, because I want to make sure that if I'm talking to you, I don't look away. It kind of looks weird if I look completely away. Hopefully this is a solid setup. Okay, let's now see if I got like a... No, this drives me crazy. Okay, I'm gonna have to look away. Right, so let's see now I'm gonna remove the build products and develop, kind of reissue that from scratch. See how long does this adding package takes. Because I can also, it's not so bad, it's a couple of seconds. Okay, it's much better than the Git thing. That the Git thing could take a long time, the Git clone, because JUCE has a million things in their history. So this is okay. I think next time I configure this is going to be cached, and it should be generally fine for now. Sometimes I like to just point it to a local folder. It's a little faster. So I might think about switching to that in a bit. Okay, so there is here like a lot of basic things that I'm setting up to do with how a project should be set up. There's a lot of things that I made here that are really well tested in projects. Like, for example, you really want to use the static runtime linking. We talk about that. There's a bunch of stuff about unit tests here, which we will not go into right now, but we might in the future. But the main reason why I made this, I wanted to have a setup, and that's how I like to work in all my projects. I want to have a setup where instead of just having a singular project, this has modules with JUCE modules that have shared code, and it's got plugins and apps. And we would really need those because we are very likely going to create a lot of things in a shared library, and we're going to test them in multiple projects. And maybe I'll even extract a lot of this library to some other repo very, very soon. So I want to be prepared for this. I don't want to just build everything into my project. There's actually going to be very, very little code in the actual game project. Okay, so first thing I'm going to do, I only need a couple of things. I might keep minimal plugin templates, and I think that's all I need. Do I want the new plugin templates? I can maybe keep that. It's got some parameter stuff. Sure, I'll keep the new plugin template. Let's remove this other one. Remove all these. Get it out of the theming except for the new plugin templates. And with the apps, I can probably remove all of them except for console app and GUI app. Yeah, I can remove all of these. So console app. GUI app. Let's remove those completely. There's a bunch of modules here. I probably don't need most of them. Definitely not this one. Definitely not this one. Shared plugin helpers might be needed. We'll see that in a bit, but I probably would write that from scratch. But I just want to see that things compile for a second. And the reason why I'm doing this is now that I have this little project, I can build multiple things in it, right? I can see the console app. We can build it, see that it does something. I can build other projects. Pretty soon, when I'll have multiple projects that kind of reference different things in the library, this is going to be critical. I'm going to want to very quickly try set things without touching the main project. I'm going to spawn some GUI app, try GUI things, or I'm going to spawn a plugin to test audio things. I'll talk later about why I'm going to do this. Do some of this work as a plugin. We might actually even build the game as a plugin or a standalone plugin. So this builds the little Hello World app. That is good. And yeah, I think this is a better start. The README can probably be completely different, so I don't need the README of the templates, probably. So I can just open VS Code and say something along the lines of trying out or testing out a rhythm game. and JUCE and C++. So there's not much to say about this right now, but I can just commit all these million changes and call this like initial commit. Removed unneeded projects. Edited readme. Okay, beautiful. Here we go. So now I have a better form of the project. There's a little bit here about tests, which I never probably don't want to touch currently. But I like that already I have a lot of like the basic setup. I know that my stuff will compile. We might change the Mac default target here. There's a bunch of like Windows setups, a flag for universal binary, blah, 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 blah. Good. Okay. How's everyone doing so far? Let me know if you have any questions about what I'm doing. Why am I doing this? I'm basically working on a little rhythm game. Feel free to send comments if something looks interesting to you. Oops. All right. So a few things I need to do for my own sanity. There's little helpers that I have to do pretty much in every project, just so that I can get a good baseline and feel like I'm comfortable in this environment. Because what probably would be the first step here, like the first practical step or feature that we're going to be creating is we're going to create a sequencer. There's going to be a sequencer. It's going to play MIDI. That will be the first audio feature. I might even start just with playing MIDI files. And to do that, there's a few like necessities that I would need before I even put the interesting bits of my code, because this is the way I always thought about rhythm games is that, generally speaking, there's a model of the game. The game is like a timeline, right? I'm really simplifying here, but the idea is that there's a timeline, and the events, pre-programmed events in the level are running, and we know that a certain event happened at a certain musical time. Like for example, we're saying the beat is on bar number 4, beat number 2, something like that. Some musical position. The user hits, the button or the controller or the little dance pad. I have a dance pad. Here we would probably eventually test this with the dance pad. So this is going to be pretty cool. But the user clicks something, and then we try to look at when they pressed it, and then we can, for example, score them on how accurate they were. Sometimes rhythm games have like all kinds of like start, stop, long gestures. Sometimes there's like game events, like sometimes something happens, the user has to evade the monster and then press. We can maybe do stuff like that, but the idea is really it's all synced to this sequencer model. That's how I'm imagining the model of the game, and we're going to go into abstracting this. Hopefully we can get to that today. But I would first do a lot of setup and prepare. Yeah, so what I want to do is just basically, first of all, bring a few things in the project to, let's call it my world. My world means that I can code things in a expressive way that makes sense for how I work. So currently we have the plugin template. The reason why I made this a plugin template is that the JUCE, even though I'm not going to make it a plugin in a DAW, or maybe I would. Maybe we can think of a plugin version of this. Is the JUCE standalone template already has things like setting up audio devices and kind of hooking you up to the process block. So it's very convenient for me to think about things like this. There's already some interface for a playhead. So I think even with a standalone application, it would be useful to to think about the problem similar to a plugin. So in this case, it's going to be the standalone plugin for the new plugin template. I can actually remove something like I don't probably need AU and VST3 for now, maybe in the future. Yeah, let's change some naming stuff here, so that things are kind of in our little world. Let's see. There's a processor and an editor here. The editor is the UI for the plugin or the app in this case. Is synth. This actually is a synth. Company name is me. Here. I'm gonna call this something like, well, maybe I should already start by just putting this in a different folder. So let's change this to rhythm game. So we need to connect it to this other CMake. Let's call it rhythm game. Listen true. MIDI input true. Okay. Copy plugin after build. Whatever. Vector. Let's call it something like EAPL. My plugins. Plugin code is RYGM. Rhythm game. There's going to be a better name for this as we move along. Blah, 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 config flag. So there's probably better ways to set all this stuff up, and we will. So far, this is okay, I think. There's some namespace stuff I really just set up for this to look like what I like. Oh, just plugin ID. So it doesn't like the fact that my company name has space inside. It's something like just bundle ID, something like com dot Yalamir dot rhythm game. This is the Apple specific stuff. What else does he want? Did I specify this correctly? Oh, it's just bundle ID. Go. Okay. Good. The fact that this isn't the global namespace, I'm going to start setting up decent namespaces here, which would quickly, hopefully, make sense once we build this up. So here I have something that's in the repo. It's called processor base. It's basically just something that has a bunch of defaults. Okay. Bunch of things here I probably need to not do. But this is just a bunch of boilerplate. The main thing I want to do is I want to namespace this instead of calling it plugin helpers. I want to call it something like EA audio. EA's me, Yalamir. Processor base is fine. Is there anything else in this module? A few helpers. Okay. Probably don't need all of these, but it's okay. Processor base. That's kind of okay. And here my rhythm game, the rhythm game would probably be namespace, something like namespace EA audio plugins or something, rhythm game. And this would just be processor base. Same here, so namespace EA audio plugins. Kind of weird that it's a game and we call this plugin, but I might call it something else. Right. These games that I made here are not needed. We can just remove them. We probably would need to find another way to actually use the parameters when we're actually creating them. Oh, did I not set this up? I thought I did. No need for these parameters for now. Process block just does nothing. This is storing the state. We probably don't even need that for now, so I can remove save and load state for now. I'd probably circle back to that. No need for that. This needs to be outside of this namespace because this is a static function that JUCE expects us to implement. This would be like a audio plugins rhythm game. Oh, let's just call it processor now. So rhythm game. Yes, and now we can just change this and call this a processor. Yes, this looks good. Default constructor does nothing, but probably be doing something pretty shortly. These can be private. Let's look at the editor now. The editor takes in. This one is going to be in another namespace called EA GUI. Something like plugins. Rhythm game. You'll see pretty soon when we start to write the library stuff while all this nesting is needed, because we are going to create things in those all these levels of nesting that would make sense for that level. Like we'll have generic UI things, we're going to have generic plugin things. Yeah, so it's okay. This goes to it's going to take the. So for this, usually because this is going to be quite a long namespace, usually I do something like using DSP or namespace DSP equals audio plugins rhythm game. So this will be the namespace that we're going to use, so we can then pass in something like DSP processor JUCE. JUCE, and this will be the processor JUCE. It's good. And I can just change this class name to editor. New GUI. Plugins rhythm game editor. This looks pretty simplified. Let's see if this runs. Warning, it is buffer, right? Because I am not using the buffer. This warning is a good one. What else? Unused parameters, right? I'm not using the parameters. I can just remove this for now. Good. It built. Give me a blank window. Let's see that my changes are now correct. I wonder if I can tell it to always launch on this desktop, because there's a couple of them, and how can it only launch at this monitor? Is there a way for me to do that? Like, for example, if I click here, can I tell you be here on this desktop always? If I close it and launch it again. Yes, okay, that worked. Good. How are everyone doing? Hopefully you're okay. Hopefully the quality is good. Feel free to let me know if you have questions. I'm going to commit this and do something like modify. Plugin templates to have the basic structure and correct names. That's good. All right. And let's see if we can start by so first what might be good is to make a very basic synthesizer so that we will hear any kind of sound, and then I'm gonna write a MIDI player that's gonna be a little bit more advanced. So synth. Oh, first of all, I don't want to call this module share plugin helpers. I want to change this module to, let's call it something like EA audio common. Let's call it like this, EA audio common. It needs a different file names. So the way the plugin format works is that you need to specify these files. So they are exactly the same name as the module, as H and CPP. This lets the JUCE system kind of read and parse through modules, including their dependencies. And then you have this little thing in the header, which is like metadata. And this is read, even if you're using the producer or something, this is read by that to make the build system work. For example, connect to JUCE audio utils or whatever it is that your module is requiring. So EA audio common. Common. Or maybe the name needs to be this, and this needs to be EA audio common. Okay. I did this because I also want to start to have a common that's not audio. Let's use that opportunity to make that. Okay, so the question is, what's up? Did you write the game engine yet, or are you going to write the game like from scratch? Yes, I'm going to be doing that. I'm going to write the game from scratch, including the engine. There is going to be some sort of an engine here, even though like nothing generic. It's going to be specific to this game, I think. So I'm going to be writing hopefully everything. This is using JUCE, so I don't need to write like a low-level rendering code, but I would need to write everything to do with the sequencer and the model and how to make it kind of trigger graphics and stuff like that. This game is going to be a rhythm game of sorts, so there's going to be probably something to do with the timeline is going to be flowing. There's going to be some MIDI events that will will show up on screen before they show up. So there's going to be, for example, let's say you will need to hit a button at the right time. Something would play this for you on screen before it happens, so you'd kind of see a preview, and then you would know when you have to press the note or the controller and play something. So it's going to be a fun thing to do this interaction. Always wanted to try that. Awesome. So this is going to be open source. Hopefully some of the libraries here will make it easy for somebody else to do the same thing. Definitely the parts that deal with the sequencer, right? The actual timing mechanism. Those are going to be cool. Those are probably not going to be so different from a rhythm game and, something like an actual musical sequencer. So these is going to be using, similar techniques to things that I've done in plugins like BeatScholar or even ARP that have the sequencer model to them. Like in the sense that, it's going to work with different tempos and loops and patterns that change because, the level might change pattern midway through to some other pattern in a musical way. So there's going to be a lot of considerations to doing that. There might even be a little sampler here, probably just basic, but just something to play sounds. Might even just use a JUCE sampler just so that I'll get something going, but then later we might develop a better sampler. We'll see. Let's see how far we want to take the music element of this. Yeah, so I'm just setting up a couple of modules. Here I have this thing called EA Audio Common. I'm going to set up another module just because I know I always need to do that. It's going to be called just EA Common. This one is going to have a bunch of shared things. There'll probably be one for UI. There's going to be there's going to be probably a million modules by the time we're ending this. So yeah, so this EA Common, I'm going to make it a little fast. We'll call it EA Common. For a start, this is actually just going to have a bunch of definitions, just because there's a few things that I think are just too boring to type, and it might be much nicer to like import them into the namespace. They're just so common, and I probably need to also bring in my data structures. So this will be the next thing here. So I don't need any of this stuff. I just need this little thing is going to be called EA Common. This only needs to depend on JUCE core. It might need JUCE events. For a start, I might start with JUCE events, but I might make it my own events model pretty soon. But we'll start with that. No need for anything here. This would do something common. Almost always do that in every model that I make. And for now, this would just include common. But pretty soon there's going to be things here. Then this module, EA Audio Common, will depend on EA Common. And what EA Common would do is, first of all, it's going to import a few things that I always want to have imported. One of them is, let's include JUCE core. And this should do something like using JUCE string, using JUCE file, using JUCE memory block, and there's a couple of others that I always want. Oh, using JUCE ignore unused. So I like that one. We'll see what else. Probably a few other common functions that I just always want to have. And I did it because, for example, here in processor base, there's a bunch of JUCE string here, and I don't want to type JUCE string everywhere. It drives me crazy. I use their string in my namespace. So this I should including EA Common. And once I reload CMake, it should be able to make that connection and let me do that, and also not explicitly use JUCE memory block. Blah, blah, blah. As you can see, I didn't like using namespace JUCE. I'm not bringing entire namespace JUCE. I'm bringing very specific types that I know are all over my code base, and they'll be all over the code base here. So there's absolutely no reason to type those explicitly every single time. Usually I'm also not importing that much of the EA namespace. I'm going to import some of the stuff just to like the audio namespace or the GUI namespace. So like I'm not going to import component but I might import component to the GUI namespace, which we're about to go over. Are we good? Yay common. Did I add that model? No. Yay common. So this needs to be part of the list that JUCE parses. Delete help it. What did I miss? Yay common, that's fine. Yay common, that's common. What else is missing here? Let's include here. I think the problem is this plugin actually goes with the wrong name. This is called now EA Audio Common. So Audio Common. Now, if I'll go to this little base class, yes, it can parse it. It's all good. And it knows what string is. I don't need to type the string. That's good. While I'm here, let's also check out this module. Make another common here. Common. These are all just going to be things that everything in this module is going to need. So mostly definitions and sometimes there's going to be a couple of functions there. With some more advanced modules, like some modules need stuff like preprocessor things before they include things, modules that wrap libraries. So it's good practice in my opinion to just have this little common thing. In JUCE, they do this like explicitly in the module header, and that forces like an organizational structure that I don't love. So I'm trying to do this. Instead I can include common. And now that I've included this, I can also add my own definition. So for example, I can do namespace audio. And here I can do something like using buffer equals JUCE audio buffer float. This is going to save a lot. Using JUCE MIDI buffer. Using JUCE audio processor. Using JUCE audio processor editor. Just a few things that are just going to be so annoying to type in the context of audio, the audio namespace. So I don't need to do this. I don't need to do this. Let's actually implement process block here. There's process block. So now I can just call this buffer. So much nicer. So much nicer. This is not needed. This else branch is totally not needed. What other cleanup do I need to do? This just helps me remove some noise from my project. I'm gonna use comment. I need this. I need this. These are some JUCE boilerplates that I definitely don't need. Okay. That is nicer. Good. So this is just these are things I always do to make code cleaner and more readable, hopefully. These files I probably can just remove, right? Probably don't need them. Yeah, let's remove them. Those are totally legacy from the past. So I imported all these stuff into my audio namespace. My common namespace has just a few imports here. So it's definitely not all of JUCE. It's just like a few things that are incredibly common and would make my code much, hopefully, nicer to read and to reason about within my namespace. So I'm not globally importing these. Then the game, or the game plugin in this case, which is but we'll see pretty soon how the game plugin would just wrap a thing that's not a plugin. So this can also call itself buffer. This is just like an editor. No need for this. No need for this. This is now called a buffer. If you ever need a buffer of double, you can explicitly state that. 99.9% of buffers are going to be the float buffers. Yeah, so just remove a bit of noise. I hate noise. I like things that say what they do. Like, I don't need to know more information about this buffer. I don't need to know the full template type every time I'm calling an audio processing function. So that's okay. That's good. Let's see if everything builds. And then I'm going to commit this, and we can start with a bit of audio, little audio things. Awesome. This compiles, runs. Let's commit everything and say edit. Basic splits modules with EA common and EA audio common. Imported common classes into the correct namespace. Good. So we got this going. Let's now do something a bit more valuable. How's everyone doing, by the way? I know I have some people watching here on different networks, YouTube, LinkedIn, Twitch, Instagram. I can just see, I can put it on screen because it's Instagram, but I see an awesome comment from Indonesia. That's awesome. Just checking to see the world has not exploded just yet. All right. Next up, I want to be creating the most basic synthesizer that can play some sort of sound. This is going to be a horrible synthesizer, so don't judge me for what I'm about to do. But the idea for this is I'm going to make like a boilerplate-free synthesizer that plays a sine wave or maybe square wave that can just be called from the processor. So from the processor, I can do something like, hey, process these synth with these MIDI notes, play. Something like that. It should be something very simple, like extremely low setup to use. And just so that I can start hearing some sounds, one of the reasons why I made this as a plugin is we can test this plugin in a DAW. I can put some MIDI before I start this whole sequencing aspect of it. Good. Oh, let's do something else. Do I do that right now? I'll do it in a bit. There's some UI stuff that I probably needed to start setting up, but I would start them soon. All right, we get some boilerplate out of the way. Let's make the most basic synth we can think about. So, under this audio common, I'm gonna call it like a synth, or it's not even synth, like a basic synth. Good. I'm gonna make a class. I'm gonna call it synth. Basic synth. Right. One of the reasons why I have this common thing, like I don't, is that I always want to include all these, definitions, just like here. Like I don't want to keep, putting my own definition. Like I should each module should refer to its own, like, common definitions and common using stuff. Macros might be here, like all kinds of, or includes. It's helpful for a module to be condensed like this. So I need to add this file to be basicsynth.cpp. I'll probably expose it, so I might need the H in here as well. Good. So namespace, EA audio, struct basic synth, and this would start. So this would actually would start by inheriting from MPE synthesizer. Do I need to actually inherit from MPE synthesizer? I think I do, right? Yeah, so MPE synthesizer. Yeah, I think I just need to inherit from it. So I inherit from MPE synthesizer, but I also need the voice. So I need something like a basic synth voice, and this should inherit from MPE synthesizer voice. It's good. And let's see what are the things I have to implement, like the pure virtual function. So there's a few things that I am forced to do when I'm inheriting. These are all of these. CLAN would just complete those for me. Note started, note stopped, pressure change, pitch bend change, timbre. Okay, well, I can treat this to be buffer. Yes, one of the things that I've always hated, by the way, it's so stupid that JUCE does this. Output buffer, start sample, num samples. That make no sense. So first of all, what I'm going to do is, just to save myself future typing, I'm going to make a base class to abstract some of this. So first of all, that I would not have to necessarily implement all of these. Like, for example, I might not deal with these, right? Why are these pure virtuals that I have to deal with? I might not have pressure in my synth. It's kind of annoying to put it. So let's call this something like a voice base that inherits from JUCE MPE synthesizer voice. Instead of implementing all these here, I'm going to implement them here. And add just default implementations. These two are probably needed almost always, but like it would be hard to do a voice without these, so I have to think. Maybe I'll keep those pure virtual. Yeah, let's keep this because note start and stop I think will be difficult. And render next block is knitted, but I'm going to do my own virtual function here because I don't like this interface. I hated that it gives me output start and number of samples. I think I should just get a clean buffer. And one of the features of audio, like the reason why they did this is that because the buffer in a synth, a JUCE synth, can actually be a split. Like for example, let's say the buffer size of the DAW is 128 samples. What JUCE does is, for example, a voice might start midway through the buffer, right, in some position. So it splits the block. Then it would, it would call that some of the voices with smaller size blocks so that they can come in exactly at the right place. However, this is pretty confusing because two things are confusing here. One is that I think that it's much easier to just operate on a buffer instead of like a partial buffer. It make coding this much easier. The other thing is, I think JUCE expects, and I'm going to test it in a second, but I think JUCE actually expects for the synth to add to this buffer, for the voice to, almost like a and I think this is actually kind of confusing. I'm gonna test this in a second, but I think it would be much easier to just write into the buffer instead of adding. It would make most actual DSP functions easier. So I don't like this interface. I'm going to wrap this into my own little interface. And it was going to look something like process, virtual void process. And this thing is going to take a buffer float. And it should be also no except to kind of help the compiler a little bit to optimize this if possible. So for now, let me start by adding, I'm going to call this buffers. So one of the things I always do in every project is that I start to write free functions that do buffer operations. I find that to be very important for the expression of the code. So let's do that. Let's call this buffers. Add this to the build. Audio. Okay, so the first function we need, and this is going to be such a common function in audio, is I'm going to call this get sub. So one big feature of audio buffer that is for some reason not used enough is that audio buffer can own the data, like std vector, like it can allocate memory and own the data, but it can also reference a chunk of another audio buffer. Just like, so for example, it can take the middle or just one channel or just some of the samples. And it's actually a super useful thing because this, instead of having all this verbosity in our code telling us which chunk to operate on, we can just create a buffer that references that chunk. It's a very useful way to do things. So one function would be, in this case, be const buffer. Let's call it source, and then it would take something like int start sample, int length. And what this would return, it would be a no except, like almost all the functions here. But this would return, let's look at the constructor for audio buffer. One of these constructors of audio buffer lets you do exactly this. So it takes the pointer to the data, number of channels, start symbol, and num samples. So it's just going to create that thing for us. So this is going to return source get array of oh sorry, this is not const, this has to be const. Get array of right pointers, and else did it say? Where was I? What was the order of the... So this one has... refers to num channels, start sample, num samples. Okay, so number of channels is source get num channels, start sample, and length. And we're actually probably going to use a bunch of variations on this very shortly. So there's going to be like all kinds of partial buffers that we're going to get. But this is going to help us. So we got this. The other thing we might need for this to work the way I like it is, yeah, so what this is going to be, the first thing it's going to be do is that this little render next block is going to, instead of including comment, it's going to include buffers, and this would do buffers get sub from this output buffer, start sample, num samples. So it's going to be something like O to sub equals this, and this will give us, this is not a non-allocating, non-copying, it's just reorganizing these pointers, creating a very nice stack object that just has the pointers in it. If you ever read about how audio buffer itself, the JUCE audio buffer is laid out, it's very cool. They do this thing where the members of it, let's see if we can find the members. So it's got these things that are like number of channels, size, but then after that, it's got information for how much data it actually owns. And then if it needs to allocate memory, it allocates it in this thing called the heap block. But basically, if you don't use heap block, if you don't allocate any memory, all these stuff are just plain stack variables. Like these are a couple of pointers. This is size t, int, bool. So everything except for the allocated data of heap block is basically just a small stack struct, which you can pass very quickly, and you can create local ones on the audio thread. It's pretty efficient. You just have to make sure that you're using this. If you're constructing one, you're using this particular constructor that I used that gives you that. So I create it, and then I'm going to call process with this sub. This is the and then this is what's going to come into the voice instead of this. All right. So the synth voice then now needs to implement 3 functions. It needs to inherit from voice base. Now it needs to inherit note started, note stopped, and where's process? Virtual void process. Did not find it. Then am I blind? Virtual void process. Hold on. Changed keyboards, I see. What do you mean by changed keyboards? What did I change? Oh, well, thank you very much. Thank you. I appreciate that. This should also show me... Oh, there it is. Is it here? It should also show me the process function from voice base. Why is it not showing me that? Virtual void process, blah, 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 blah. Maybe just clown is acting weird. Because this needs to be... This is now let me do this. And override it. I'm not sure why it didn't do that, but that's what should happen. So now I should implement just these 3 functions in my voice. This would very soon go into a voice base class. It's like shared, and not in this synth. So yeah, so my basic synth voice, and I also might need to take care of the stuff that I'm pretty sure we can probably look at the JUCE examples in a second. I think that this is actually expecting me to add, and I want to also add the voice basic option to set up a buffer for me to write into instead of adding into an existing buffer, but it needs to be a shared buffer, which would yeah, maybe change things here. Okay, so one thing to do is I can start with a use ADSR. This is actually pretty critical. I'm going to do ADSR note on here, and then ADSR note off, and then if I don't allow tail off, I need to clear right now. And then when I process this, the ADSR should probably be something along the lines of ADSR dot. It's called apply envelope buffer. Start sample buffer get name samples, right? Buffer dot get num. I'm not sure why my CLine is going crazy. Maybe because I'm on the beta version of CLine. Let's switch to the non-beta version. Then we should just if ADSR is not active, clear current note. And we should probably do something that makes sound, like the sine wave or something like that. Let's use. Do I have something like that already? Should have something like that ready to go. Oh. Thank you so much. I'm so glad you like my keyboard playing. Maybe I'll take a break after a while and do some live keyboard playing. I have the keyboard right here next to me. You can see it. I wanted to play some Beatles songs or do something fun on the piano. Okay. How does the process block? There's like a render next. How do you call this? Render next block. Other than what's the name of the synth function process? I'm going to start by just playing white noise here because I think I think that I still would have a problem with this expecting me to add, and I don't want to add. I want to process. So I think that, but I think basically let's write some very horrible white noise just for the sake of testing. JUCE random, and then the processing function was in that for. In channel equals 0, channel am I gonna do, you know what I'm gonna do is I just want to put it on the first channel, so I'm gonna do for in sample equals 0, sample less than buffer. Okay, I gotta restart CLine because it's acting up. If it doesn't work, I'll switch from the beta to the the full version. Okay. I think the purpose of this is that I just like new basic synth voice or something. This is the idea, but I need to improve this a little bit. To improve this flow a little bit. So, okay, am I back? Did I get completion or no? Am I completely dead? Oh, first of all, this is not buffer float. That's maybe why this doesn't work so well, because I'm... Okay, so this is just me. That's also why I didn't auto-complete it, because I screwed up the buffer. Okay, buffer get num samples, sample, and then... Okay, and then what I'm going to do is... on the I'm just going to work on the first channel. So go to channel data equals buffer get right pointer 0. Kind of assuming there's more than 0 channels here, and then channel data sample equals to random next float. This thing takes a range, so I think this is 0 to 1, right? Let's see, next floats. This is probably not the best way to do this. I might need to fill a table and do something better than what I'm just doing, but we're going to start with just the most basic thing so we can hear a sound. This is not going to be the actual processing. I just want to read this. So 0 to 1. Okay. So instead, I'm going to get the range. So auto next equals this. And then this would have something like a JUCE JMap, which would scale this from next from -1 to 1, which would be a better audio range. This might actually be really loud, so I might play some gain in a bit, but let's start with, let's just do it from, I don't know. We'll see. After I do this, I want to copy this to the other channels. So back to the buffers, I need something that says void copy to all channels, buffer source, or just buffer in this case, and then it's something like int the source channel. And this is actually super common when you want to do some mono operation, and then just copy it everywhere. That's super common. So the default should be probably 0. Copy to all channels, no accept, like all these here. And this would be something like 4 int channel 0, channel smaller than buffer.get channels, plus channel. And then if channel isn't source channel, then I'm going to switch it to CPP because I want to do something here. I want to also use using FVO equals JUCE float vector operations. This class is going to use a lot of those. These are buffer or SIMD operations that JUCE uses, which lets you do these like vectorized math and run multiple processes at the same time. So it's going to be much faster to do something like copy or multiply, which we would probably do a lot of. So FVO copy from do that, then go to source data equals buffer get read pointer source channel, and then equals buffer get read pointer channel. So copy from, I think it's first a destination, right? Destination is the target, then the source, then how many samples, which is buffer.get num samples. So if this buffer only had one channel, it's basically going to do nothing, or just for loop once do nothing. But for any other channel, it's going to copy the source into it. This is a super useful function. I'm using that similar thing all the time. So like a case like this, like this, so we can have a straight loop doing the random. In the future, we're going to read from a table. That's what we're probably going to do with an actual sine wave. Just read through the one channel, and then when we finish this, we can just do buffers copy to all channels. Buffer the default is just copy from 0, so from the first one. So we're just good to do that. Then for now, I'm just going to do something like buffer apply gain, because this might be too loud. I have no idea how loud it's going to be, so we might tweak with this number. We got it. Add this and clear. Okay, that's good. Then let's not have just one voice, but 4 index equals 0, index smaller than 4 voices. And then add 4 voices. So we got this part, and then we need to should be a render next block call, right? What's the name of the process function here of the synth? Render next subblock. Oh, maybe to the parent of this. Render next block. Yes, okay. The reason why I'm doing this is just for my own sake, is that I just hate these 2 extra arguments. They're just not needed. I want to do something like process, which takes buffer, MIDI buffer, MIDI. Also, it's a no accept. Some extra compiler permutations might be unlocking here. And then this would call render next block with the buffer, with the MIDI, and I'm going to assume this is 0 buffer.get num samples. Is this accepting const MIDI buffer? No problem. I can make it a const MIDI buffer. Good. So this is my basic synth. As everyone knows, I'm streaming this on different platforms. If you're watching this on YouTube, Twitch, X, Instagram, Facebook, whatever, feel free to comment. I should be able to see the comments here, and I can put it on screen and explain why and how I'm doing something. I'm making a little rhythm game in JUCE. I'm just making a little bit that makes some noise, so we'll hear a synthesizer. Then I'll switch it to a slightly better synthesizer, and then I'm going to switch to a little MIDI player sequencer, and following that, start to do something to do with the actual game. Maybe some visualizing or controls. We'll see. Okay, so I've run this, and why did I do all this? Because now back to the plugin. I should be able to do in the processor, do something like a basic synth. Oh, and I should also initialize ADSR with the correct sample rate. So that's also a thing. Which is something also weird that JUCE isn't doing in their API. My synth APIs always do that. Basically, something like a prepare call that takes it's like a double SR int block size, and then this will just go through all the voices. But it also needs to do this specific type of the voice, which kind of sucks. I hate that I'm going to do what I'm doing now because the voices are stored as a base class. I hate that. There's absolutely nothing that that's required. Like in my synth classes, we'll probably write that in a later. In my synth class, this is not stored as a base class. Like there's no reason to do a base class of voice. I just have a templated synth with the type of voice, and then it's stored in a better way in memory. It doesn't need to be an array of pointers. It can just be a straight up array, and there's no need for what this horrible mess that I'm going to do, which is dynamic casting voice to a cast the voice to this. This is horrible. This is totally the wrong thing to do, but it's going to work for now. Before I write a better way to do this, this is just the way JUCE does this. I could have stored it. I could have stored like my own, like one way to do this is also I can do like a std vector of voice pointer and do my own like synth voices or something. And then when I add this, I can have this so that something like, O2 new voice equals new basic synth voice. I create this here, and then I can place it back here for safekeeping, and then add it there. Then I don't need to do this dynamic cast here. I have this with the correct type, but this is a stupid way to do this. There's no need to, for performance reasons too. Like there's no reason to store it as the way JUCE stores owned array. Like it's a vector of pointers. It's just not a good way to do this. Like you want all the voices right next to each other in memory. This is just not efficient. I don't like this. Anyway, so I did this stuff, and then I can just with each of my voices, I can do something like a void prepare double SR in block size. Block size would be needed for like temporary buffers and stuff like that, but I don't need right now. But the ADSR does need the simple rate SR. So we'll start with that. Voice prepare. Now I can just loop on my list of voices and do prepare SR block size. So that's really the way to do this. Rhythm game with MPE features. Yes, it's possible this would actually have MPE features in it. Yeah, we're definitely going to see. Like, there's definitely going to be. It's very possible that there'll be like multi aftertouch or something involved in the control. I'm still thinking about the exact controls, but also I think that JUCE's MPE synthesizer is better implemented than the JUCE synthesizer. It's a better syntax. It's much nicer to work with the MPE classes too, even if you're just doing regular MIDI. So I like it. Okay, so why did I do all of this? So that my processor plugin in my, now there's going to be a prepare to play. I need to implement that as well. Prepare to play needs to do synth prepare. Just forward whatever the host or the sound card or whatever is giving me. Done. And then process block just needs to do synth process with buffer or MIDI messages. That's pretty much it. We can also do something like JUCE, scoped, no denormals. Which should help a bit as well with all these like close to zero numbers that could happen. So this makes some operations faster. Okay, we got this. Let's see where we are. We should be getting sound. I didn't. It's possible that I screwed up something about the actual synth. So there you go. Bunch of asserts. Let's see why. What did I forget? Oh, I passed it as sample rate of 0 because oh, the synth itself also needs to be prepared. Is that what happens there? Did I forget something? So the synth, when I'm preparing it, do I just like set sample rate? Yeah, okay, so the synth itself also needs to know the sample rate. Okay, let's set up some MIDI control. I don't know if you can hear this, but this actually plays this. But it's plays, but it's screwed up because of the thing that I talked about earlier. But it does work. I don't know if you can see what happens. What's happening? Can you hear that? Let's see if you can hear my audio. Let's send it out. Hopefully, you can hear this beautiful white noise. I'm just hitting notes on my keyboard. You can't really see that. You'll see that soon. But whenever I hit a note, you can see it kind of rises up because the envelope is there with some default parameters. And I'll leave and it stops. The problem is once I start to play multiple voices, I'm going to start with the first voice. It's pretty loud in here. I hope it's not too loud for you. Hope it's not like taking over the world. I'll make it softer so that hopefully you won't die from how bad the white noise is. Let me know how the levels are coming through on the stream. So I'm starting. Let's just point the camera at my fingers. So I'm gonna press this. Plays the noise. Now you're gonna hear a bug when I add a new voice. See what happened? It stopped the previous voice and started a new voice. This is not good, right? What I should have heard is basically polyphony, right? So there was no polyphony in this situation. So I need to fix this, and I kind of know why why that happens. But let's commit this first, just so that I'll make some progress. So let's do something like edit initial buffer functions and a basic white noise synth. Still buggy. Okay, so this was just the that's what I'll get some thing. So there, I just also want to cover this comment. Long live Project RNL. I will keep the hope alive that you make more music. I do make more music. And if you notice, there's I think I put it on this channel a few weeks ago. I posted this amazing track I did with Omri Abramov, which was a Pat Metheny song where both of us are playing it. I think hopefully you like it. It's and I'm trying to I would be making new music and new tracks. Yeah, you should check it out. Definitely check out some of the things on this channel, the Almir channel. There's some great stuff from the last few years that I recorded with or from RNL. And different drummers, like Sharon from RNL plays on some of them. Sharon, drummer. Dekeldville, also RNL, plays on some of the tracks. It's really good stuff. Yogev Gabay plays on one of the tracks. Really, really good songs that we made in this band. So it's all like electroacoustic with a saxophone, but hopefully you'll appreciate the vibes. Okay. Anyway, back here. The bug that I have, I think it's the bug that I have, is let's look at the voice class. The problem is that in my voice class is that JUCE expects that I would actually add whatever is happening in the voice to the existing buffer. I hate that semantic. I think it's confusing and it's not making it clear. Making it clear what the what's it called? What the voice is doing. Like if I add this, it's making it difficult for me to write like plain DSP, just like a process, like a common processor. I'm going to need to every time apply some adding operations. So what I could do, of course, is I can make a buffer, right? I can make a temporary buffer here right into my own buffer, and then process it on top of the, and then kind of just edit at the end. The problem is, I don't like that. I don't like the idea that that it's a different buffer from every voice. Like this is just gonna ruin my cache locality. So I can just create one buffer for the entire synth. So here's what I'm gonna do. What I'm gonna do is this basic synth voice class. It's this thing is going to have not this basic synth, sorry, the voice base class. This is going to have a pointer. So this is going to just be a buffer pointer, and we'll find a better way to extract this pretty soon. But this is going to be something like a buffer pointer of type. Sorry, a buffer pointer that's it's more like voice buffer, and then equals not PTR. And instead of doing what I just did with render next block, what I'm going to do is instead of grabbing the buffer here, what it's going to do is going to get a sub, because the voice doesn't need to process anything. It can basically look at itself as a clean input. So what it needs is I need the sub actually needs to be taken from the voice buffer instead of the output buffer. Start sample is going to be 0 in this case, and then I'm just going to clear it and pass that sub buffer into the block. Once I'm finished, I can make a copy operation, which I'm just going to need to add for my little buffers class. So something like void copy, and JUCE has it, but this is going to be a much nicer way to call this. So it's going to be const buffer source buffer target no accept. And what it's going to do is that num channels is going to be the minimum number of source get num channels, and target get num channels because it might be overlapping, but then we don't know what to do with it. And then for int channel is less than num channels plus channel. So source data is the source get read pointer channel. Target data is target get write pointer channel. And then we're going to use our favorite FVO, the vectorize operation. Copy. I should also do something like that. The num samples is min source get num samples target get num samples, so we don't overflow if one of them is bigger. And then we copy target source data num samples. So just do a vectorized copy for each of the channels. Okay. That's good. So, and then I should just be able to do, now that I'm finished with this, copy, and in this case, I don't need copy, I need mix. I forgot about that. So I need to do the same thing, just with mix. Mix is going to look identical to this. Oh, sorry, not to this, to this. It's going to look identical, but it does add, right? This is basically the same thing. Could probably template this and add FEO or something, but this is the idea. And then while I'm here, I'm going to add something else that I probably would need in the future, which is mix gain. And this would have float gain. And this again would look the same way, just with add, with multiply. I could probably template this with a lambda or something. Multiplier. So it's the opposite. Also good. Kind of look like this. And we can template this. Now we have 3 functions. It's probably good to do something like template. Type name func. Like let's call it void process. Process channels. Const buffer source buffer target. Func. Leo here says this is cool. Thank you. Really like this. Hopefully this will be a fun thing. We're just writing a little bit of like abstraction on the synth part, the basic synth part. We're just going to use to test, and then we can get a good hopefully sequencer happening. We'll break some MIDI files, and then we can start building on top of that to make a little game for ourselves. So fun stuff. So cross channel, source, target, no accept, very important. And then the idea is that this would do this, but then it would just call the function with target data, source data. Let me call this source target, because I'll get completely confused if this is the so it's going function takes 3 arguments basically. That should allow me to do something like, so the copy would be something like autofunc equals it's going to look like something like const float source float target in num samples, and what it's going to do is copy target source samples. So this is the function, and then I can just call process channels source target func. So I can simplify this to this. Is this correct? Let's call it something like source data, something target data. I don't know why FVO takes the target first, always confusing for me. But anyway, this the idea is that now I can do the same thing with this, and this would be add. Can remove this. Same with mix. So mix gain is the same thing, but mix gain would need to capture gain because it comes from the inputs of the function. So this will let me do FU and multiply with gain, and I can remove all this. So this is much nicer. The idea is that now I have let me give this a better name. Let's call it process all channels, because that's where it is. Like it's a way to process all channels with source buffer and target buffer with a function. This is an internal, like internal implementation only templates, and that allowed me to kind of reduce some of the boilerplates and do more of a declarative style that just explicitly says which function I'm calling, and it's going to call that for every function, but still do this little calculation where make sure not to overflow the number of samples and channels. So copy, mix, and mix gain. Good. Those are going to come in extremely handy. And then let's go back to my synth. The synth. So it does. So each thing after it calls a specific voice, it operates on the same buffer, voice buffer. And then it's going to do buffers, mix, sub into the output buffer. That's really what it is. How's everyone doing so far? Hopefully all this makes sense. Now there's a little bit of mechanics to do for this to work. It's still not, I need to start abstracting this correctly, by the way, so that's clean on the user side. But this buffer needs to be passed in from the synth into all the voices. I'm now going to do this manually, but this should not be done manually. Basically, when I call, for example, when I create the synth, for example, I should be passing that somehow, and we need to think of like either through the constructor. But the mechanic stuff is actually the synth is going to hold this thing called the voice buffer. The voice buffer has to change, so voice buffer actually has to set voice buffer, or not buffer float. Sorry, it's just a buffer. Whatever, set size. I'm just gonna assume, you know what? I'm not gonna assume it's 2 channels. I'm going to pass in the number of channels, num channels, because this could be mono or something. So so set size number of channels and then block size. So we're setting it to the maximum number of samples that could be passed in. And then when I do this, now I'm just gonna do something pretty horrible. It's not a nice clean side. It's not a skull side, but it would work basically. I can just do new voice. Voice buffer equals my voice buffer. Not the best way to do this. We need to improve on this pretty soon. But that is that when we're initializing this voice-based class, very quickly after doing this, we're passing the voice buffer. This would go into the library pretty soon, so I want this abstracted correctly. There might be a few synthesizers running in our little app. And then when the specific voice, this is the voice that currently does white noise. The idea is that it should completely not be aware that it's running over some other voice buffer. Like it has its own buffer, it's clean, it can just write into it. And I think most synth expects something like this. Now let's see. Basically what I was trying to solve is I was trying to make sure that my little white noise synth, which we will hear shortly, can play polyphonically. Oh, what I forgot. Oh, good. So now when I prepare it, I should also pass it the get total number of output channels. So now when I'm preparing the synth from the plugin, from the game, and make sure it's initialized correctly. No, I was missing a, what was I missing? Oh, just buffer. Okay. Unused start sample. Yeah, because I don't need the start sample because, oh, no, I actually do need the start sample. It's not because I do need to write it in the correct place in the buffer. So the target buff is going to be buffers get sub of the output buffer start sample num samples. And when we mix, we need to mix in. This is one reason, by the way, why all these buffer functions are useful. All these buffer functions are useful because now we can just do simple operations like mix on. We don't have to work with like slices of the buffer. We can just have a buffer, which is itself a slice of the buffer, but the logical operation is much easier. It's just like, hey, take this. Imagine that is the full buffer. So there's a good question here. Why do you want the white noise mono? So the reason why I want the white noise mono is because, first of all, this white noise is just for test. So I don't care so much about like actual stereo waveforms. Stereo, we could think about like something that does a stereo noise, but a stereo noise is actually really weird because white noise is random. So if I put different noise in each channel, it's kind of confusing sound. We can try it. It's kind of confusing sounding, and I think mono white noise is a bit more coherent for like the regular use case. But I'm just doing this for now just because it's the simplest way to test things, and I'm not actually going to play white noise in the final project. So it's I just want to make sure that we know what we're hearing. We can hear the envelope, for example, clear, because with a stereo white noise it might confuse exactly the shape of the envelope. So I'm just going to test the infrastructure around my synth, and I'm probably going to replace it with an actual like a square wave or something more interesting, and we can put something that has unison in it, that has detune between the oscillators, or anything cooler than just white noise. Hope that makes sense. Okay, let's see if I got this correctly. If this worked as I'm expecting, this should just play polyphonically. So, okay, this is one voice. It works. I'm hit my key. It works. Okay, perfect. So it didn't sound so good because I'm playing stupid white noise. But now I played it. You could hear it playing. Now this is adding, removing. Good. So this was the basics of what I wanted to do. Like I want to make sure that each voice can logically look at something like process, kind of ignore the fact that it's mixing itself with other voices. But I also didn't want each voice to have its own buffer. I want to make sure that I'm reusing the same piece of memory for the entire synth, because I know that at least in the JUCE synthesizer, voices are not processed at the same time. Their voices they perform one after the other. So I know that there's no contention. There's no multi-threading happening here. So I know there's no contention over this, and I can reuse this great cache locality and basically keep working with the same buffer as much as I can. I can, there's other things that I can reuse here, which we can talk about, but this is the basic idea. We probably need to do something like set envelope parameters from the UI or something. We can enhance this, but this is a good start. So let's just clean this up a tiny bit before I'm committing this. One thing is that I'm gonna call this let's call it voice space. Let's make a voice space class. Put it in the build. So basic synth voice space CP. It's still not so well constructed, but we would improve this over time. Let's take this to the H here. good. Let's move the namespace here. And this actually needs to also include the buffers header because of the little helper functions we've used. Not much to this, but so we're going to use this. This should now include voice base. The namespace is going to be here. So there's a few. I'm just gonna move this over here, and we can reflect more about what I've done. And most of everything here that's in basic synth, by the way, I can probably abstract. There's almost nothing specific here. It's so stuff that I can probably create as like a synthesizer base or something like that that's more common, including the voice buffer and all that stuff. Like this should probably be probably the next thing I need to do. But basically, let's just build and see that this worked. So looking at the interface here, code interface, not user interface. The interface here is that I've first of all created a voice base class that does a few things. One is that it implements all these virtual functions because not all synth need pressure, pitch, timbre, even though our synth might actually use those, but later. And the main thing that it does is that it overrides the JUCE render next block function and adds my little logic to create a subwoofer and kind of make a nice clean call site in the specific voice. So that something like the basic synth voice can just say, okay, process with the buffer. Like it doesn't need to know the start, doesn't need to know the end, doesn't need to add and mix different buffers together from previous voices. It can be very clean, and everything else is kind of taken care of by the base class. The synth holds that buffer because it's the same buffer to all voices, and it's got a vector of the strongly typed voices. And this is just because JUCE doesn't store these strong types. It stores a base class of the type, and we needed to know exactly what those voices are. We can't just assume they're just voices. We need to know that they, for example, have an ADSR. Pretty soon they'll have an oscillator. Like there's going to be specifics that we need to reference in those. And then we had to like do a little callback with like a call set with this where I'm calling prepare on all these. And now that I look at this, pretty much all this code very shortly can be moved into a synthesizer base class. Maybe even a templated one, and this is going to be pretty nice. So let's start with let's commit added basic or also fixed white noise synth to use correct polyphony and refactored base class to abstract buffer mixing between voices. Okay, that's not bad. That is not bad. How's everyone doing? Any questions so far? All right. So next up is I am going to just make sure that the world's not collapsing. Yeah, so the one thing I noticed that is that about the synth is that basically, so the question is about JUCE, and the question I think specifically is what is it? So JUCE is a framework, it's a library that's used mostly for plugins and audio apps. It's very, very common, like nowadays a lot of the new plugin companies, audio plugin companies use that. And we're using that, for example, in Modalix to create our plugins. A lot of other companies I work with are using JUCE. It abstracts a bunch of things, like for example, how VST3 works and how AU works, but it also does a bunch of things to do with like UI. And it's got a lot of tools that I'm interacting with. Like for example, here I'm using JUCE ADSR or JUCE Random. These are all JUCE classes. And yeah, it's all in C++. So it's a C++ framework. Generally speaking, most code we're writing for audio is usually in C++ or a language kind of like C++, like Rust or something. But and yeah, so it's all C++, and you can see me using here. These are all C++ stuff like stud vector. This is a C++, the C++ version of a dynamic array. And the concept of this and why we really need C++ for this is that this has to run very quickly. So if we're running an audio buffer in 44,100 sample rate, that means we're gonna get calls to do math for the synth for 44,100 times a second. So it's very quick, and we have to be very, very efficient in the way we're doing the audio bits. So for example, when I'm calling this process thing, this is going to be constantly called all the time. This process function is going to call me and hammer me with a bunch of calls, and I need to really return very quickly. That's also why I did all this work on doing this voice buffer stuff, because I wanted to make sure that when I'm called and I'm working with these buffers on all the voices, that I have like a little bit of memory that I'm always reusing, because accessing memory could be slow. So I'm trying to minimize the effect that I might have because of it. That makes sense. Hey, just started coding recently, so this explanation was solid gold, bro. Thank you. Oh, all right, awesome. I'm really glad you've enjoyed this. Yeah, I know this is kind of falling into the heat of it, and hopefully this makes sense. I'm sure there's a lot of details here that I'm kind of not explaining as thoroughly as I can, like about syntax and why this is something. So whatever there's something that's unclear, I'm happy to take a little pause and go over things. Also, it helps me to maybe see the broader context, because sometimes that could be tunnel vision. Yeah, so the one thing I wanted to do is I didn't like basically what I realized is that nothing here is actually specific to the synth. I can actually pretty much abstract this whole thing. I wonder, let me see something. This is interesting now, because I just had a very deep thought. I don't know if what I'm suggesting would actually work. Because when I'm doing add voice, it's gonna add it to some the JUCE add voice basically. Okay. New voices add. This is an owned array. I wonder, can owned array oh, that's interesting. I wonder if I can maybe like hack the performance here, because I just realized that even though JUCE is calling this, so this is a total low level optimization I just thought about. The JUCE synth class holds the thing in something called an owned array. An owned array is a vector dynamic array of pointers. That's how JUCE does it in their synthesizer classes. The thing is, that's actually not very efficient, because it means that every voice is allocated in a different place in memory. And when we're iterating over the voices, we could be jumping into different places. In the past, like in some other code that I have, I actually wrote my own version of that, which just allocates them one next to each other in a very cache-friendly way. And that's a big improvement. However, I'm starting to think that maybe I should be able to, as long as I make sure that the voices are cleared before the owned array tries to reallocate them, I should be able to kind of, instead of allocating them here on the heap, I should actually be able to use something like a like in place new and allocate them on the stack. This would be awesome. Okay, so this might be something I'll do a little bit next. So I think it should be done. I need to test if it's actually going to work. Anyway, I think this whole thing, everything I'm doing here. So what I'm going to do is I'm going to create a little test for a bass class. It's going to be something like just like a synth bass. Inheriting from JUCE Synthesizer. I don't love the big inheritance change that I'm doing here, but I think it's probably needed. Maybe not. I'm not sure. I need to rethink this. But the idea is that I'm going to pass everything here, so that this would just be something like let's call this add. Yeah, this is probably fine. So I can do this like void add voices. And do something like template type in T. Add voices with it. Add voices. Let's just use like in num voices. This voice buffer is actually going to be a part of the synth bass, and then yeah, probably this whole thing just to be a template. So this whole thing will be a template. The vector is of type T. It's going to be synth voices. Basically, will be the whole thing just a template. Voice buffer is just going to be the voice buffer of the synth. This prepare prepare function. Same thing, it's going to be here. And then what else did I do here? Oh, process. Process is just like it calls another function, so pretty straightforward. So it's just these three functions, and none of those actually need to, like, there's nothing specific here. I can literally remove this whole class, and I can, you know what, because I have fixed number of voices, I can even do something like synth bass in num voices. With some default or something, and then this would be add voices, num voices. So when I initialize this, I just let you know what how many voices I have, and this would do all the boilerplate. And basically now this class is not needed at all. I don't even need the basic synth. Basic synth. This is all going to go to the library or to the like common part of the library in a few seconds. And this whole thing would just be something like using basic synth equals you just call it a synth or an MPE synth or something. MPE synth. And this is an MPE synth with basic synth voice. That's it. It's just like it's an instantiation of the template, but it's not an actual type. So I can take all this. I'll put this here for now because it's all kind of connected. This is a new T, not basic synth voice. Yeah, that's pretty much it, right? See if this works. Great, white noise plays beautifully. Let's commit this. Moved generic synth setup to a common templated synth. So now I don't even have to write a synth. I just need to write. This is why I did all of this, right? The idea is that now I'm a user of this. All I need to do is implement these functions: started, stopped, process, prepare. I might need to add the number of channels here actually, but this is generally the idea. And oh, I might have needed to. This might need to be virtual. We'll think about that in a second. Anyway, but the idea is that all you have to do is implement these, and then the synth itself can just do straight up processing with a buffer. No need to write, no need to mix. For example, this is the logic that I have for the white noise. Like for example, I can even refactor some of this to be clean. Like I can do something like this is like struct, white noise. I'm gonna do actually implement this a bit better very shortly. But the idea is that let's remove this, and what this does is void process buffer no accept. Let's have one function that says void process channel. Just taking a float channel in some samples. Load channel data. So this is not needed. Num samples of this. This is the process channel function. The process buffer function is just doing process channel buffer get right pointer 0 buffer get num channels, and then it does copy to all channel plugin. Might need to move this white noise thing to another file. Should I even remove the put gain here? Maybe I can put gain separately from this. So this has a white noise class, white noise. All this is doing white noise process buffer, right? So I think this makes the voice. I'm gonna move the white noise class to like something else in a second. But this should make it very clear what this class is doing, right? There's no mixing here. There's no partial buffers stuff. It's all kind of abstracted away. I'm doing very straight ahead processing. I'm taking the white noise, it processes it in the buffer. I'm applying some gain, and then I apply the envelope over it. And then if the envelope is not active, I clear. That's really what the most basic operation of the synth is. And then the kind of the framework takes care of a little bit of plumbing, subbuffers, mixing the voices together, etc. I do hear a bug in my code. My voice is not doing what it should. Why is that? Because get num samples and not num channels. That's better. Okay, awesome. So now we probably now need to maybe improve this. This might need to use a table. This might actually need to use a shared table in the sense that this might need a, like for example, let's say this would be a real oscillator. I don't want to have I might have just write a big array and then just give it samples from that array. That would be another, a better way to do this probably than actually calling JUCE random. Yeah, but this is the general gist of the idea. So let's commit this. Basic synth, abstracted white noise into its own class. There you go. That makes sense. How everyone feeling today? All right. Did Muay Thai coding ate healthy? Muay Thai coding, I like that. Muay Thai coding would love to see, like a Anderson Silva doing Muay Thai coding in the Matrix. That'll be amazing. question. Coding with metal or lo-fi? I've coded with a bunch of lo-fi stuff. I definitely like that. Metal, I can code with some instrumental metal music. There's a really cool band. They're kind of metal. Their name is The Algorithm. They're really cool for coding. Yeah. I like instrumental music when I code, so it's hard for me to listen to anything with lyrics. So it would have to be, I don't know, it would have to be something like you know, Animals as Leaders maybe, but they're also very intense. So maybe in specific points I can play that kind of music, or Liquid Tension Experiment or something like that. I like to jump. I like guitar music a lot when I'm coding. Like I can't put it on stream, but I would love to, you know, like if I can listen to, you know, Pliny. Pliny is an awesome music for coding. Steve Vai albums. I love to code with Steve Vai. I can even enjoy coding with somebody like Yngwie Malmsteen. I think that's awesome. Like any kind of instrumental guitar music is great, in my opinion, for coding. Also, if you've not heard it, Alon Tamir from RNL has an amazing instrumental album. You should listen to that. Beautiful music on that one. Also with Pliny and Virgil Donati. And oh, that's awesome. The Doom Eternal soundtrack. That is very cool. You know, it's interesting. I just met, I don't think he wrote that soundtrack, or maybe he did. So I just met Mick Gordon like a couple of weeks ago. I have a photo with him in my Instagram. I just met him. He's an awesome guy. He's using the Modalix plugins. I had a good talk with him. Did he compose Doom Eternal as well? I'm trying to see. Yes. Okay. So he also composed that. Yeah. So he is such a good composer. If you look at my Instagram, you'll see a photo of me and Mick Gordon, and we've had an awesome nerdy hang. He's such a smart person, and I really like his Doom soundtracks and his everything that he writes. So good. He's a god. Yes. Yeah, so good. You know, it's awesome because when he showed me how he's using our plugins, he's, you know, he has discovered, you know, the edges of our plugins. He knows so much about them. So that was also so interesting to see how he thinks and how he works. Is such a brilliant musician. Also, he has an amazing legendary blog post on like the issues that he's had with on the production of Doom. So definitely check it out if you haven't. I've read that blog like 5 times. It's so good. Bethesda, yeah, Bethesda, whatever you say their name. Yeah. So that again, I didn't go into the Doom 3 gonna suck again. What do you mean? Doom 3 is one of the best games ever. I love Doom 3. I'm sorry. I think Doom 3 might be my favorite Doom game. I know people like to shit on that game now because it's slow. I love that game. I think it's so good. It's so immersive. Doom 3 is, to me, one of the pinnacles of gaming. But it's controversial, super controversial. I don't know why people don't give it the right amount of attention. I love that game. Also, the full engine is open source. for Doom 3, which is great. It's unlike the first Dooms, it's written in C++, and it's a very cool piece of work to check out. So before I continue, I'm kind of contemplating, do I take a break, get some food, come back for another stream? Maybe a good idea. All right. So I hope you're enjoying this. I'm going to take a little food break and start the next version of the stream probably in like maybe an hour or something like that. Thank you, everyone. I really appreciate you joining. I respect you all. Such unique opinions. The world better. When people can hold crazy conspiracy about the Doom 3 was good. Yes, I know it's very controversial. I know that it's, you know, it's not everyone's favorite game. I know people, but I don't know. Maybe it's just me. I felt like I spent a lot of time playing Doom 3 when it came out, and I think it's just it's such a special game because it's not like the other Dooms. And I also love, you know, Doom 1, Doom 2, and Doom. The new Doom. I love those games as well. But that one was for me like such a trip. Also, by the way, something people don't realize, if you play now, if you'll play I don't know if you, I haven't played it on the computer in a while, but if you get Doom 3 on the PS5, they simplified the mechanics. It's super weird. You know, like in the original, one of the cool things they did in the original Doom 3 game is that you had to alternate the flashlight and the weapon. So basically, if you're like, you know, if you have the flashlight, somebody could shooting and you have to take it off, take the weapon. And because everything is so dark, you almost always have to have the flashlight on. So it basically really added to the horror. And now, if you get it on the PS5, they kind of simplified it. So now you just always have the flashlight. You never take it off. And it's, I know it kind of lost this huge element of horror. It's like it made the game more like a regular shooter. And it's, I don't know, I feel it's like it's very weird that they did that. On the computer, hopefully they didn't change it, but I don't know, maybe they thought it was going to be complicated for PlayStation people. But I love that. It scared the shit out of me when I was playing it. Okay, there's two versions. I think I just bought 1 3-pack on the Steam sale. I don't know what's happening on what would be the version you need to get. You know, I bought the original. Like I had a box. I think I had a box version with like a DVD back then when I played it. And I think I bought it again like years after. But I don't remember what the difference between versions. I think BFG edition has the extension connected. Like there's an extension with more levels. But I don't remember if on the computer, if on the BFG version you still get the toggling of the flashlight. I don't know. Maybe someone who knows better than me can say it. But it's simply weird they removed it. All right, I'm gonna take a break, get some food or something, and then I'll come back probably an hour or so for another stream. Thank you all for watching, and see you soon.